Ever wondered why you can add two strings or two numbers with the same plus operator in Python, or why you can use the same function name for different tasks in C++? The magic behind this is operator and function overloading. Operator overloading allows us to define how operators like plus, *, asterisk, and behave when used with objects of a class. This provides a natural and intuitive syntax, extending the functionality of operators to user-defined types. On the other hand, function overloading lets us define multiple functions with the same name but different parameters. This flexibility allows functions to perform different tasks based on the provided arguments. These concepts play a crucial role in enhancing the flexibility and intuitiveness of a programming language, enabling us to define multiple behaviors for operators and functions. So, operator and function overloading are not just fancy terms, they're powerful tools in a programmer's arsenal. Let's start by understanding what operator overloading is. It's a technique in object-oriented programming that allows you to redefine how operators like plus, minus, multiplication, division, and equality work with objects of a class you've created. Imagine you've developed a class for mathematical vectors. By default, if you try to add two objects of this class using the plus operator, you'll likely run into an error. Why? Because Python or any other language you might be using doesn't know how to add two objects of your custom class. That's where operator overloading comes in. It lets you, as the programmer, define exactly what should happen when someone tries to add two objects of your class using the plus operator. In the case of our vector class, you might want the plus operator to perform vector addition. To do this, you would define a method within your class that outlines the necessary calculation. In Python, this method is called. So when you overload the plus operator for your vector class, you're essentially telling Python, hey, when someone tries to use the plus operator with two objects of my vector class, use my customized method to figure out what to do. This extends the functionality of operators to user-defined types, providing a natural and intuitive syntax for working with objects. But remember, with great power comes great responsibility. Operator overloading can make your code more readable and intuitive, but it can also lead to confusion if not used judiciously. Always ensure your overloaded operators make sense in the context of your class and are consistent with the general expectations of the operator's behavior. In summary, operator overloading is a powerful tool in object-oriented programming, allowing you to define the behavior of operators for your custom classes. It provides a natural syntax for interacting with your objects and can lead to cleaner, more readable code. That's operator overloading for you, a way to redefine how operators work with your custom objects. Now that we have a grip on operator overloading, let's move on to function overloading. Function overloading, like its operator counterpart, is a technique that allows you to define multiple functions with the same name but different parameter types or a different number of parameters. Now, why would you want to do this, you might ask? The answer is simple. It provides flexibility and convenience in function usage. To put it in simple terms, function overloading allows functions to perform different tasks based on the provided arguments. Let's use the example of a print details function. Imagine you have a software that handles data about people, their names, ages, occupations, and so on. Now, sometimes you want to print just the name and age of a person, while other times you might want to print their name and occupation. Instead of creating two separate functions like print name and age and print name and occupation, wouldn't it be easier to have one print details function that can handle both these tasks? That's where function overloading comes into play. You can define two versions of the print details function, one that takes two strings as parameters for name and occupation, and one that takes a string and an integer for name and age. When you call print details with a string and an integer, the function that handles name and age is called. When you call it with two strings, the function that handles name and occupation is called. In essence, function overloading allows you to write cleaner, more intuitive code. It reduces the need for a multitude of similar functions with slightly different names, making your code easier to read and maintain. One important thing to remember while overloading functions is that the function name remains the same, but the parameter list must be different. It can differ in the number of parameters, types of parameters, or both. And there you have it, function overloading, a technique to make your functions more flexible and versatile. Operator and function overloading sound great, but there are some important considerations to keep in mind. Firstly, it's important to mention that not all programming languages support operator and function overloading in the same way. Languages such as Python, C++, and Java typically allow operator overloading, letting you redefine how standard operators like plus, minus, or division work when used with objects of a class. On the other hand, how function overloading is supported can vary from language to language. Some, like C++, offer traditional function overloading, while others, like Python, might lean more towards using default values or variable length argument lists. Another key consideration is method signatures. In function overloading, the appropriate function is chosen based on the method signature, which includes the name and parameters of the function. But with operator overloading, method names are predefined. For instance, in Python, you'd use E to overload the plus operator. Consistency is also crucial. The power of overloading comes with the responsibility to maintain clarity in your code. It's best to avoid overloading operators or functions in a way that could potentially confuse users or other developers. Stick with intuitive, logical implementations that align with the expected behavior of the operators or functions you're overloading. Of course, we can't forget about documentation. It's vital to provide clear documentation that guides users on the supported overloads and their expected behavior. This can save a lot of time and confusion down the road. Lastly, let's talk about error handling. When you're overloading, it's a good idea to consider edge cases and provide informative error messages. This can help to prevent unexpected behavior and make debugging easier if something does go wrong. So there you have it. As exciting as operator and function overloading can be, they're tools that should be used with care. Remember, with great power comes great responsibility. Use operator and function overloading wisely. Let's quickly summarize what we've learned about operator and function overloading. Starting with operator overloading, it's a technique that enables you to define custom behaviors for standard operators when they're used with objects of a class. This means you can dictate how operators like plus, minus, multiplication, and division work when used with your custom objects. The purpose? To provide a more natural and intuitive syntax for working with objects, and to extend the functionality of operators to your user-defined types. On the other hand, we have function overloading. This allows you to define multiple functions with the same name, but with different parameter types or a different number of parameters. The correct function is then chosen based on the arguments you provide when calling the function. The aim here is to bring flexibility and convenience in function usage, allowing functions to perform different tasks based on the provided arguments. Remember though, not all programming languages support operator and function overloading in the same way. For instance, while Python, C++, and Java commonly support operator overloading, function overloading may be supported differently across languages. It's always best to check the specifics for your language of choice. In both cases, the key is in the method signatures. For function overloading, the appropriate function is chosen based on the method signature, which includes the name and parameters. In operator overloading, the method names are predefined. And let's not forget about consistency. Overloading should always be done in a way that maintains clarity in your code. Avoid overloading operators or functions in a way that could confuse other developers or users. Always document your code properly to guide users on the supported overloads and their expected behavior. And don't forget to handle edge cases and provide informative error messages to prevent unexpected behavior. And that wraps up our discussion on operator and function overloading. Remember, these techniques are tools to make your code more flexible, intuitive, and powerful. Happy coding!